Which of the following choices will not, that's a not, lead to a correct solution to the given equation? So I'm thinking all of these work except one. We want to find the one that doesn't. So you always want to, when you're solving for x, you want to get rid of your fractions usually because it makes it easier. People tend to make mistakes with fractions. And how you do that is you multiply both sides of the equation by the same number that will allow you to cancel your denominators with that number. So the first thing, it says multiply both sides of the equation by a 4. So we're going to multiply both sides by a 4. So if we multiply this side by 4, that's going to give us a 24x. This is going to cancel with that 4, so we're going to have a negative 11. This, multiply this side by 4, the 4 cancels, minus 6x. Here, the 4 cancels, so that's going to be plus 5. So that's a good one. That would eventually lead to an answer, so that's good. Now, look at the second one. This one, they're not getting rid of the fractions first. They're going to add and subtract first. So they're going to add 6x over 4 to the left side. So plus 6x over 4. That could be good because you've got your x's on both sides. And then they're going to add negative 6 to the right side. Negative 6x to the right side. This is a y because you're just moving one variable with an x in it to left and the other back to the right. So that is probably going to be our answer. But let's make sure maybe there's two that do not work. So rewrite 6x as 24x over 4. So they're going to rewrite this 6x with a fraction as a denominator of 4. So 1 will go into 4. 4 times 6 is 24x. That would work because you're changing that so that you can combine it with this over here. So that would be okay. And then the last one, we're going to add add 11/4 to both sides. So that's adding 11/4 to this side, add 11/4 to this side. That will work because you have more steps to do, but that will still work. So the only answer is that adding where we add 6x over 4 to one side and negative 6x to the other. That doesn't lead you anywhere. So we're talking more about clearing fractions, get rid of fractions. And it's like finding a common denominator and using that denominator to get rid of your fractions. So if you look at those two denominators, you have a 4 and a 12. If you were going to add them, but we're not doing that, but if you were going to add them, your common denominator would be 12 because 12 goes into 12 and 4 goes into 12. So we're going to use that to multiply everything on this side by the same number and everything on this side. Now, they're asking us, would 4 work? So I've put 4 different here, and we're going to try 4. When we multiply everything on the left side by 4, that's distributive property, so we're multiplying this term by 4 over 1. We're multiplying this term by 4 over 1. And then we're multiplying this by 4. That's distributive property. Okay, we're just distributing it out so we can cancel. It's easier to cancel that way. So when we cancel, the 4 cancels. That's good. We want to get rid of the fraction. But here, do we get rid of the fraction when we cancel the 4 and the 12? No, we still have a denominator. So 4 isn't going to work. It will not help us clear the fractions. Next is 8. So if we make this, multiply it by 8 over 1. Multiply this by 8 over 1. And 23 times 8. It doesn't matter on that because it's two integers multiplying together. So right here, the 4 will go into 4 once. 4 goes in 8 twice. That's good. We got rid of the fraction. Here again, 4 will go into 8 twice, and 4 will go into 12 3 times. It doesn't matter that we have a 2 on top. The problem is we still have a fraction in the denominator. So the 8 will not work. So this does not work. This don't work. So let's try 12. Well, 12 will work, right? Because everything will cancel. 4 will go into 4 once. 4 goes into 12 3 times. Whoops. Here the 12s go to 1s, and this you just multiply. So 12 works. So 12 works. The next one is 48. Now 12 is the smallest one, but 48 will still work because 4 will go into 48 and 12 will go into 48. So 48 does work. So we're going to use 12 or 48 because I'm multiplying this term by 48 over 1, and this term right here by 48 over 1, which cancels. And then I'll just multiply this by 48. And this one will cancel too. What was that, a 4? So 12 and 48 work.